In the previous video, we had a deep look at the vscsi tool that allowed us to give us an idea as to the I/O patterns of our virtual machine. In this video, we are going to take a look at the vmkfstools that allow us to really manipulate the file system used by ESXi to our requirements. So we are going to take a look at the vmkfstools as well as something called parted util, which allows us to manipulate partitions at a very deep level as well, and in conjunction with the vmkfstools it actually can be extremely powerful and can actually get us out of a bind, especially when the graphical user interface tools fail. So with that, we're going to move to the command line and take a look at vmkfstools. So we are back at the server 192.168.0.201, and by keying in vmkfstools help, this is basically what we see here. So we have vmkfstools piped to more. So vmkfstools with a capital C will create a file system, either a vmfs5 system. You can't create a vmfs3 anymore. And then what it allows us to also do is define what the device name it would be. So that would be a /vmfs/devices/disks and then a canonical name on which that file system would actually be created. And you would basically set the file system name here as well. You also have other options, which is basically you can span across multiple partitions with this and grow with the capital G. Again, we don't tend to do this nowadays because there is plenty of storage available, unlike in the old days of ESXi. So you are hardly ever in a situation where there is not enough room available to grow. And then there are new techniques that storage arrays have that allow us to transparently grow the amount of actual physical disk or storage capacity that's actually available to us without having to invoke this. So this part of the tool was really handy when we are actually dealing with real spinning disks and really were concerned about partitions and so on. So usually the only reason one would look at vmkfstools would be if needed to create a new a vmfs5 in case of a disaster recovery, and then we needed to make some copies and so on. So that would be a use of this vmkfs tools. So one set of options which we just briefly looked at are options for file systems, and then of course we have the options for the virtual disks as well. So once you have your vmfs file system actually set up, you can then create virtual disks there with the disk format. Obviously 3 possibilities here: zeroed, thick, thin, and eager zeroed. Many of the things around the adapters have been deprecated. A few interesting things are object type is you can either create a file, a vsan, or vwall. So again, if you are going low level and there is something you need to do that you cannot do in the graphical user interface, this is where you would actually do it. You can clear out a disk, which means you can basically write zeros to it, which would obviously inflate it as well. The J would inflate the disk. You can delete the virtual disk after you've created it. You can rename a virtual disk. You can clone a virtual disk. When you create it, you can actually define what those options are as well, which we saw, like the /d, the -d disk format option that we had there. When you clone, you can also specify exactly what kind of a disk format you want to clone to. Of course, you need the vmfs path to do that. Sometimes with SCSI drives, there were problems with locks and things of that nature. That would create problems, especially in cluster mode. So again, having this ability to lock or break locks or release locks, learn resets, target reset, bus reset, you can do things like this through only the command line and with vmkfstools, and you could do it in a relatively controlled way because this is a tool specified by VMware. Again, these kind of options of locking and breaking locks are best done with VMware support's approval, but these things are available, and this is the tool in which they are available. What we can do is to take a look at our ESX, CLI, storage, NMP, device list. We can pipe it to more, and this obviously gives us the canonical names that we were looking for, and that would be used in as input into the command for vmkfstools. Quit out of that. That's how you would do that. Then there is a utility which is a partition management utility. You have probably heard of it. Let's clear the screen so the output comes on top. Parted with a capital U util. You key that. So you can say parted util get, and then you'll get the partitions. If you specify the actual disk, you can actually set partitions, the partition number. So you can set on a raw disk, basically you can say partition number 1, start sector. It's usually 2048 for VMFS file systems, and end sector, that is about 44 sectors before the end. Usually the type is a very specific UUID that I'll show you how to get, and the attribute is usually a 0, which means there are no special attributes that are needed. Now I know I rushed past this. The reason again is that this is something that we hardly ever do anymore. Get table and set partition tables. We can look at one of our disks and see what that looks like. So let's see if we can retrieve the previous command, and we have parted util again, and what we can do is to get the partition table for that disk. So parted util get p table slash vmfs slash devices slash disks slash. So where I right click and I hit the enter key, and you can see that the partition table is of GPT type, but this is partition 1, starts at 2048, that's the ending. And then this is very interesting because this is the UUID for the VMFS file system, which if you are looking to understand what the various type of these GUIDs are, this is how you would do that. And so if I say parted util show IDs, I will get a list of all the of those IDs. So the GUIDs for VMFS, diagnostic, for vSAN, which is obviously new, so parted util is being kept up to date in case you need to go really low level. And then of course you have the standard Linux LVM swap and so on. Microsoft apparently has reserved something as well, but the one that is important, and I guess in the future for vSAN, if that's how you want to manipulate vSAN, presumably only after VMware support has asked you to do that, really the only one that one would ever use would be to create a partition that would hold a standard VMFS file system. Some of the other commands that are useful, we can clear this out, are really the disk, the virtual disk creation commands. And the reason this is useful is that if you recall, when you create a virtual disk, you actually get the flat and the VMDK itself, so you actually create 2 files. Well, using vmkfstools, if you create the file, those 2 are actually taken care of automatically. So to create that virtual disk, we are going to shift to one of our VMFS volumes. So that is cd slash vmfs slash volumes. We do an ls there, and we see we have a data store 200G, so we can cd to that. ta tab, I can go with A. We are there. vmkfstools dash create say 1024 megabyte, and we will call it packed disk.vmdk, and that file is actually created. Now let's do an ls, and you will see that you actually have two files that have been created. One is your flat vmdk file, and then you have the regular vmdk file as well. So this command operates at the virtual disk level and understands the actual configuration and how a vmdk is actually configured. So we've seen how we can create using the vmkfstools command. We can create virtual disk that understands the actual internals of that vmdk file, including the fat file. And we looked at the various other options of how to create the thin disk, how to inflate it, extend it, clone it, remove it, and so on. That's all available if you look at the help option for vmkfstools. We also looked at the partition utility and how to get the partition table with get ptbl, and then set the partition table with set ptbl. Most important part is to actually make sure the partition is for vmfs, so you need the proper GUID. You can get the GUID through the show GUIDs options of partitutil. So those are very low-level tools, I understand that, but these are extremely useful tools for us as well. So with that, we come to the end of this video, and the next video is a complete section on backup and recovery of vSphere 6 deployment. I look forward to seeing you on that video.